Okay, hello. Remainders theorem. The concept behind remainders theorem is quite simple, but for some reason, I don't know, it comes off as very confusing, but it's really, really simple, okay? And that's what I've tried to explain with this few in this single line here. That's to say that p of x divided by, if you divide p of x by the binomial x plus a, the remainder you would get. Sometimes we need just the remainder. We are not really concerned about the quotient, right? And I'll show you one of those examples. The remainder you would get would be p of minus a. That's to say, whatever a is, just plug it back into the original, into p of x, and then you have the remainder. And we'll do that with two examples. Okay, with three examples, actually. I'll say that again. You have p of x dividing something, right? A binomial in the form x plus a, right? So the remainder you're going to get after division, just take the negation of that value for a, right, and plug it into p of x. We'll do a couple of examples. It's quite simple. I don't think you can miss it. Okay, so let's have this, and say we want to divide this, and we want to find out what the remainder is. So we'll divide it first, figure out the remainder, and then we'll test with the remainders theorem. Okay, so we've done this before in the other video, right, when we tried to divide this, but we'll just do it again. We have 2x squared plus x minus 6, and we have x plus 2. The method around this is quite simple. We said you have to divide, then you multiply. So you divide just the first by the first, right? Then you multiply all. Okay, then after that you just subtract, and then you bring down. Right? Okay, so I think we have too much red, so I'm just going to switch to another color. Okay, so you divide, then you multiply, you subtract, and then you bring down. So let's try that. You divide the first by the first, so we have 2x. Then you use your answer to multiply everything. You're multiplying all. So you'd have 2x squared. 2x times 2 would give you plus 4x. And then we subtract, right? Subtract. Subtract this 2 here, you would have 0. Subtract this, that's x minus plus. So when you do that, you just have minus 3x. Minus 3x. So let's go again. Okay, hold on. We need to bring down this minus 6. So minus 6. So let's go again. 2x divide x. So we divide the first one. X divided 3x would have minus 3. We're dividing the first by the first. Then you take that and multiply everything you have here. You would have minus 3x minus 6. Then you subtract. This would give you 0, 0. Okay, so basically for this one, our remainder is 0. Let's test our theory to say that if I wanted to know what the remainder is, then all I needed to do was plug in the negation of this 2 here. So basically, I just need to plug in minus 2 inside this. That would mean I can plug in minus 2. My remainder would be equal to 2 bracket minus 2 all squared plus minus 2 minus 6. So let's work out the math. Minus 2 squared is 4, positive 4. 4 times 2 is 4. Then minus 2. Sorry, 4 times 2 is 8 rather, my bad. 4 times 2 is 8. Then minus 2 minus 6. 8 minus 2 is 6. Then 6 minus 6 is 0. 6 minus 6 is 0. Right? So again, you're saying the remainder you have here is the remainder you got from doing the whole math. Again, we'll do this example very quickly. We did it last time, but we'll just do it again, and then we'll test out our theory. Okay, yeah, I said I was going to mention when it's useful, right? Sometimes we want to know whether x plus a is a factor of p of x. This applies to polynomials that are really large. So sometimes we want to know whether x plus a is a factor of p of x. So all you do is just plug in, solve for p of minus a, and then if you get 0, then you know it's a factor, right? It's that simple. This one, I'm going to push through the long division also very quickly. Remember, we're trying to confirm, when we're done, to confirm the remainders theorem. This is going to be 2x squared plus 0x minus 1. Remember I said we need to put a 0 there. And we're dividing by x minus 3. So let's go. You divide the first by the first, you would have 2x. And then when you multiply, you would have 2x squared minus 6x. Subtract. The first would give you 0 as usual. The second would give you plus 6x. So we divide again, we'd have plus 6. That's x divide 6x. The first divide the first. And then, sorry, I forgot to bring down the minus 1. I'm sorry about that. So I always forget that. Okay, so we're back to this. X divides 6x gives us 6. We multiply that, we have 6x minus 18. So that when we subtract, we'd have 0 here, and here would have minus 1 minus minus 18. So that'll be minus 1 plus 18, which gives us 17. 17. And what I'm saying is that P of, well, I didn't call this P of x initially, but my remainder would be just the same thing as plugging plus 3 into the function above. That would be 2x 2 bracket minus 3 squared minus 1. That would be 2 by 9 minus 1, which gives you 18 minus 1, 17. So you can see your remainder theorem works. It's very simple. The remainder you get when you divide by a binomial of the form x plus a is simply, you just have to plug in the negation of the number you're adding to a. You get the negation of the a, you plug it into the numerator, and then you get your remainder. And again, we can say that x minus 3 is not a factor of 2x squared minus 1. Finally, for this one, I'm not going to do the long division. I'm just going to get my remainder straight up. My remainder is going to be, I just need to plug in positive 4. So I'm going to plug in the negation of this one here. Plug in positive 4. Inside that, I would have 2 bracket negative 4 squared plus negative 4 minus 3. So this would be 2 times 16 minus 4 minus 3. Hold on, I'm checking my math. This is 32 minus 4 minus 3. That's 32 minus 7, which gives me 25. So my remainder when I divide this is 25. And you can do the long division to confirm, or you can check out the last video that we did. So that's basically it for learning remainders theorem. In the next video, we'll solve some problems. We'll solve some problems on remainders theorem. Bye-bye.